Okay, so here we will discuss about carry look ahead adder. Carry look ahead adder. Carry look ahead adder is also known as look ahead carry adder. This one is the fastest adder. This one is the fastest adder. In previous lecture, we have discussed about binary parallel adder, and we know that binary parallel adder is the slowest adder. What is the reason behind this? The reason behind this is that in the parallel addition, second full adder is not working till it get the carry from the first full adder. Same as second full adder will not start working till it get the carry from the first full adder. That's why, because of this carry propagation, it will take huge time for the addition. So this dependency of each carry is eliminated by carry look ahead adder. In summarized way, we can say in look ahead carry adder, each carry is converted to the first carry. Each carry is converted in the form of first carry that is already known. So that if carry is already known by the each full adder, so they all will work simultaneously, and it will take only a propagation delay. It will take only smallest propagation delay. Okay, to understand this look ahead carry adder, we need a table known as truth table. So here I am making a truth table. Here I am making a truth table. Here I am making a truth table. This truth table is of full adder. This truth table is of full adder. Here this input is represented as AI, BI, CI. This output is represented as SI and CI plus 1. Okay. Now, taking the first input combination 0 0 0, second one 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and the last one 1 1 1. Okay, so in this condition sum will be 0, carry will be 0, sum is 1. Here sum is 1. In these two conditions carry will be 0. Here carry is 1, sum is 0. Here sum is 1, carry is 0. Here carry is 1, sum is 0. Here carry is 1, sum is 0. Here both sum and carry will be 1. So by using truth table, this truth table, we can calculate the equation for Ci plus 1. Ci plus 1 equals to A bar BC plus A B bar C plus A B C bar plus A B C. From first and second minterm, C is common. So after taking the common element, what we will get? We will get these all are AI, BI, CI. Na? These all are AI, BI, CI, AI, BI, CI, AI, BI, CI, AI, BI, CI. And in the last two terms, if we take ai and bi as a common element, then in bracket we will get c plus c bar. C plus c bar equals to 1. So what we will get? We will get ai and bi. Okay. Now this ci plus 1, this one is the equation of ci plus 1. Here this a XOR b is known as carry propagate function, and it is represented as pi. This ai multiplied by bi is known as carry generate function, and it is represented as gi. So that this overall carry ci plus 1 will be represented as ci multiply with pi plus gi. This one is our first equation. Okay, if we put I equals to 0 in equation number 1, I equals to 0 in equation 1, so what we will get? We will get C, what we will get? We will get C0, we will get C1. Okay, what we will get? We will get C1 equals to C0 P0 plus G0. This one is our equation number 2. If we put I equals to 1 in equation number 1, so what we will get? We will get C2 equals to C1 P1 plus G1. This one is equation number 3. Same as for the third case, if we put I equals to 2, so what we will get? We will get C3 equals to C2 P2 plus G2. Okay, is it clear to all of you? Is it clear to all of you? So in equation number 3, using equation 3 and equation 2, using equation 3 and equation 2, what we can write? Equation 3 and equation 2, what we can write? We can write C2 equals to C0 P0 plus G0, C0 P0 plus G0 into P1 plus G1. So after multiplication we will get C0 P0 P1 plus G0 P1 plus G1. Okay, so by these equation, it is clear that this carry C2 is now in the terms of starting carry C0. It is not dependent on the C1. Okay, what is P0? P0 is nothing but a XORing of A0 and B0. What is P1? Is nothing but a XORing of A1 and B1. What is G0? Is nothing but a AND operation of A0 and B0. Is it clear? So by using this expression, it is clear that any carry is not dependent on the previous carry. Each carry is dependent only in the first carry, and first carry is already known. Okay, so that's why that if the first carry is already known, so each full adder will start simultaneously. So if each full adder is starting simultaneously, so all will provide the output in the same time. Okay, so each full adder will provide output in the same time, so that it will provide the output faster as compared to the previous one. Okay, same condition. If we want to take the output of sum, if we want to take the output of sum, so what we can write here, what we can write here what we can write here we know that sum equation, we know that sum si equals to ai xor bi xor ci in the case of full adder. But ai xor bi is represented as pi. Okay, so what we can write si as, we can write si as pi xor ci. Is it clear to all of you? If we represent this equation as equation number 4, if you represent this equation as equation number 4, I think three equation I have already represent three equation, huh? Okay, so it will this will represented as equation number 3. If I represent, if I put I equals to 0 here, so what we will get, we will get s0 equals to p0 xor c0. If I put I equals to 1, then what will I get, I get s1 equals to p1 xor c1. And what is this p1, what is this p1? What is this p1? This p1 is nothing but a xor of a1 and b1. Okay, so s1 equals to a1 xor b1 xor c1. Is it clear to all of you? Same as our next condition also. When we put when we put when I put when I put I equals to 2, so what I get, s2 equals to p2 xor c2. Okay, and these c2 c1 is all by previous example, by upper mentioned equation, it is clear that this c2 is already expressed in the form of c0. It means that we can calculate sum without using the c1 carry. We can calculate c2 without using the c1, because all these c2 c1 are expressed in the form of c0. So by using c0 we can calculate anything. Okay, so this one is all about, the look ahead carry adder. The diagram of look ahead carry adder, is represented as, here, this one is c0. Now here I have mentioned g0, p0, g1, p1, g2, p2, g3 and p3. Okay, now what is p0? P0 is a xoring of a0 and b0. So here I am taking one XOR gate. I have written here a0 and b0, and when I am using a AND gate, so by using this AND gate we will get g0. Same as in this case also, here I am taking one XOR gate along with one AND gate. Here this one is a1, this one is b1. So by using this we can find out p1 and g1. Same condition will occur in the here also. This one is XOR gate, this one is NAND gate. Yeah, see. This one is A2 and this one is B2, and this one is our last condition. This one is our last condition. A3 and this one is B3. Okay, in the output side we will write C4, C3, C2 and C1 because C0 is represented in this side only. Okay, so how can we calculate it? Sum is A XOR B XOR C, that is P1 XOR C1. So from this end we will get P1, and I have written P1 here. P1 XOR C1 we will get as 1. We can easily see this one in we can easily see this in our this expression, A1 XOR B1 XOR C1. So by using these above equation we can implement this logical diagram. Okay, so same as in this case also, same as in this C3 also. Here I am taking P3 and providing these two into XOR gate. we will calculate we will calculate we will calculate S3. Okay, same condition will occur in this case also. Here we will find out S2 P2, and this C4 is directly considered as S4. Okay, so this one is all about the logic diagram. This one is all about the diagram of 4-bit look ahead carry adder. So I hope you understand this topic. Thank you so much.